talk about evaluating trig functions using reference angles. One thing to understand or remember is that a reference angle is a positive acute angle formed from the terminal side of theta to the x-axis. So if you'll go back and you'll remember from our last section, every single reference angle we had was positive, acute, and from the terminal side to the x-axis. But if the angle is acute, remember that acute angles lie in quadrant 1. Things to note about quadrant 1 is that it's positive x's and positive y's. So if you're going to want to evaluate a trig function using a reference angle, yes, you may get the correct value, but you may be off by a sign. Okay, so for example, let's just look at 120 degrees. If I have theta here being 120 degrees, that means that from the terminal side of theta to the x-axis is my reference angle. My reference angle, theta prime, notice that theta and theta prime, they close up a half rotation. So in order to find the value of theta prime, I would take that half rotation, subtract off that theta value, and I would get that theta prime is 60 degrees. However, if I were to draw theta prime, my reference angle, by itself, on a graph by itself, notice that theta prime, 60 degrees, this lies in quadrant 1, which is exactly what we had just mentioned, that acute angles lie in quadrant 1. So here's a question for you. What if I want the tangent function of 120 degrees? Now it is true that tangent's on your unit circle and you could simply just use the 120 degrees to find this. But I want to use this value to understand reference angles. So the tangent of 120 degrees, well, let's talk about this. 120 degrees lies in quadrant 2. This lies in quadrant 2. Tangent is what in quadrant 2? Well, if we go back to your rules, tangent is negative in quadrant 2. So if tangent is negative in quadrant 2, that means that a tangent of 120 is equal to tangent of its reference angle, but negative because tangent's negative in quadrant 2. So that means that this would be negative tangent 60 degrees. Well, you can go to your 60 degrees, right? So negative y over x. Remember, tangent for any circle is y over x. So go to 60 degrees on your unit circle. Here we are. We want y divided by x. Square root of 3 over 2 divided by 1 over 2. The 2's will cancel, so you'll be left with the square root of 3. But notice I'm supposed to take the negative of it, so that means I get negative square root of 3. If you were to simply evaluate this function at your beginning number, 120 degrees, you will get the exact same answer that we were getting using our reference angle, because we don't have to worry about where it's located. We know where it's located. So let's talk about a couple of examples of these so that we can understand this a little bit better. Let's use reference angles to find the exact value of the following. 135 degrees. Theta lies in quadrant 2. The function that we're talking about here is sine. Sine is positive in quadrant 2. The value of my reference angle, theta prime. In order to find that, theta and theta prime close up a half rotation. So I'll take 180. I'll subtract off my theta, and I'll get 45 degrees. So that theta prime is 45 degrees. So this says that sine of 135 degrees is equal to sine of 45 degrees. Positive sine 45 degrees. Why positive? Because we just said that the original theta is in quadrant 2 and my function is positive in quadrant 2. Alright, sine of 45 degrees is y over r. For r, I can just let this be r is 1 for a unit circle. So I can go to my unit circle, find my 45 degree mark. 45 degrees, I want the y, square root of 2 over 2. So I have the square root of 2 over 2, r is 1, so I simply get the square root of 2 over 2. Alright, notice again, I could have gotten the original value of this function, sine 135, by simply looking at 135 degrees and going to y. Now the reason that we use reference angles is because sometimes the values that we're looking at are not necessarily on the unit circle. Let's look at another one. Cosine of 4 pi over 3. Let's draw this. 4 pi over 3. 4 pi over 3 is going to land you in the third quadrant. Here's your theta, 4 pi over 3. We can always take our 4 pi over 3 and change it to degrees. Since most people are more comfortable with degrees, that's fine. Use your conversion factors. You'll get 240 degrees, which you can see that that's going to hit you in quadrant 3. So here we have theta lies in quadrant 3. My function, cosine, is, let's go back to our rules, right? Quadrant 3, cosine's negative. Cosine's negative in quadrant 3. Okay. Let's find our theta prime from our terminal side to the x-axis. There's my theta prime. In order to come up with my theta prime, I'm going to take the entire value of theta, 240 degrees, and I need to basically subtract off this half rotation up here, this top piece. So I could say minus 180 degrees. That will get me 60 degrees, so theta prime is 60 degrees. Or just, 60 degrees is pi over 3 if you want to use your radians. Well, let's talk about that. So, I have the cosine of 4 pi over 3 is equal to negative cosine pi over 3. Why negative? Because I said that the original theta lies in quadrant 3 and the cosine is negative in quadrant 3. So I say negative cosine pi over 3. So that's negative x over r. Well, let r be 1 for the unit circle. So that means that's negative. Let's go to our unit circle. Let's go to pi over 3. Here's pi over 3. The x here is a half. So I'll have 1/2. R is 1. So that means I'll just get negative a half. Okay, let's do just a couple more so we can reiterate this fact. This time I want to look at theta negative pi over 3. So again, what I want to do is I want to start out by drawing this picture. The angle here is negative, which means I will be opening down. Because if the theta is negative, I will be opening down. Well, if we look at this, let's draw our theta prime. Theta prime is from our terminal side to the x-axis. So actually, if you'll notice, our theta prime is the same location as my theta. So theta lies in quadrant 4. The function cotangent. Cotangent is, let's go to our rules, quadrant 4, cotangent is negative. Cotangent is negative in quadrant 4. Okay, Now if I want to figure out the value of theta prime, remember it's positive acute. The value here of theta is, yes, acute, however it is not positive. So if I wanted to get the value of theta prime for this, I'll simply just take the absolute value of theta. So take the absolute value of negative pi over 3 and just get pi over 3 because it does have to be positive for a reference angle. So I have my pi over 3, or just 60 degrees if you'd like to say it like that. So now let's talk about, let's talk about how this works. We've got the cotangent of a negative pi over 3 is equal to, now I said that the theta lies in quadrant 4 and the cotangent is negative. So that means that this is equal to negative cotangent of pi over 3, or 60 degrees, whichever one you'd like to use here. Okay, so that means it's negative. Cotangent is the reciprocal of the tangent, so that means it's x over y. So that means I'm going to go to my pi over 3, my 60 degrees on my unit circle. 60 degrees, I want x, 1/2, divided by the square root of 3 over 2, y. Negative 1/2 divided by the square root of 3 over 2. Oh. That means that I will get negative 1 over the square root of 3. Rationalize. I'll get negative square root of 3 over 3. Okay. Next, let's look at another one here. Let's look at tangent 14 pi over 3. This one's a little nice. Well, this one you cannot look at your unit circle because it's 14 pi over 3 is too big. Okay, you can't see it there. So let's draw our angle here. 14 pi over 3. First thing, in order to draw this, let's take 14 pi over 3 and let's break it so that we can understand this a little better. 3 goes into 14 how many full times? 4 full times. 2 is left after. So that means I have 4 full rotations. I'm sorry, that means I have 2 full rotations, I'll get to that in a minute, and 2 pi over 3 left. Okay, now, 4 pi. 4 pi is 2 pi and 2 pi, right? 2 pi is a full rotation. So I go, okay, this is positive angle. Starting from my initial side, the positive x-axis in standard position. 1 whole rotation. That takes care of this one. 1 more full rotation. That takes care of this one. And then I need to go 2 pi over 3 more. So 2 pi over 3 more. If you can't remember where 2 pi over 3 is, that's alright. Let's use our unit circle. 2 pi over 3. It's going to be in the second quadrant there. So here we've got our theta of 14 pi over 3. If you want to change it to degrees, you certainly can. 840 degrees. Alright, let's talk about this. Theta lies in quadrant 2. Tangent is negative in quadrant 2. Again, we can go back to our rules just to justify that. In quadrant 2, tangent's negative. Okay, here I have my theta prime. If I want to find my theta prime, basically we can talk about, drawing this picture without our full rotation if you'd like. Seeing it just a little bit better. Maybe helps seeing this a little bit. Basically what I did was I took out the full rotations so that we're just dealing with what's left. Notice that 2 pi over 3 and the reference angle make a complete rotation. So if I want to find the value of my reference angle, I'm going to take that half rotation pi and I'll subtract off the 2 pi over 3, so that my reference angle will give me pi over 3. Okay, now, so I'm dealing with the tangent function. The tangent of 14 pi over 3 is equal to, right, it has to be negative tangent pi over 3. Well, that means it's negative y over x. So it's negative. Let's go to pi over 3. At pi over 3, the y is square root of 3 over 2. The x is a half. Let's divide the two of them. Square root of 3 over 2, 1/2. Means you'll get negative square root of 3. Lastly, can't really see this one, it's buried there. This is the last one I want to do. Let's look at secant of a negative 17 pi over 4. First, let's draw our picture. It's a negative angle, which does mean that we are going to open down. Let's talk about 17 pi over 4. Let's break it so that we can see it just a little bit better. For example, 4 goes into 17 how many full times? 4 full times. Excuse me. And we have 1 left. We're basically going to break this so that we know each piece. Okay. Again, negative 4 pi is negative 2 pi and negative 2 pi. So I have one complete rotation and another whole complete rotation in the negative direction. So starting in my standard position, positive x-axis, I'm going to open down 1 whole time. That takes care of this one. I'm going to open down 1 whole time again. That takes care of this one. And then I want to go negative pi over 4 more. And if we can't remember where negative pi over 4 is, that's alright. Use your unit circle. Negative pi over 4 is right here, the second tick mark in the 4th quadrant. So here is our theta, negative 17 pi over 4. We can always change this to be degrees if you like. That's negative 765 degrees. Using your conversion factors, you can convert that. Now let's find our reference angle. Our reference angle is from the terminal side of our angle to the x-axis. So here we have our reference angle, theta prime. Basically what I want to do is what we did in the last example. I'd like to draw this without my complete rotations. So if I draw this, I'm going to draw this without the complete rotation. I'm going to draw a negative pi over 4. Notice that this is actually the location of my theta prime. However, theta prime does have to be positive. So that basically says that theta prime is the absolute value of negative pi over 4, or simply just pi over 4. Now your original theta lies in quadrant 4. The function we're looking at is secant. Secant is positive in quadrant 4. Here we have our rules again. Cosine and secant are positive in quadrant 4. So here we have secant's positive. So that basically says that can you see that? Let's see. Okay, there we go. Basically says that secant of a negative 17 pi over 4 is equal to positive secant of my reference angle. Okay, well, secant is the reciprocal of cosine, which means that this will be a positive r over x. Well, let's let r be 1 for the unit circle. So we're going to go, our r is 1, so that's a positive 1 over. At pi over 4, what's the value of x? At pi over 4, the value of x is square root of 2 over 2. So we have the value of square root of 2 over 2. We do have to rationalize this. I'm sorry, let's divide this out. So you get 2 over the square root of 2. You do have to rationalize this now. So you get 2 square roots of 2 over 2, simplify, the 2's will cancel, and you'll just get the square root of 2. So this is how we use reference angles to find the values of our trig functions when they cannot be found on the unit circle. Keep in mind, sometimes you can find them on the unit circle. Simply use your unit circle